In this video, we're going to look at a couple of ways of describing data, the area of descriptive statistics. We'll first review briefly what statistics and descriptive statistics are, and then we'll look at measures of central tendency for data and measures of dispersion. So when we're studying a large population, as we know, the usual procedure is to take a random sample and then try to draw conclusions about the population from the sample. When we describe characteristics of the sample, we are doing descriptive statistics. So let's look at this example. 25 students took a test. Their scores were 75, 75, 73, and so on. 25 scores are listed there. So frequently when you have data that's been collected, it will just be a collection of numbers like this in no particular order. One thing we might do is to put the numbers in order, in numerical order. This would be one possibility for organizing the data. Here are the numbers in numerical order, which you can check. 77 followed by 5 71s, a couple of 72s, and so on. This would be one possibility. Here are the numbers in order again at the top of this slide. Another possibility would be to organize the data into a frequency table. So the frequency table would look like this. We have two columns. The column on the left where we list the scores, 70 through 78, and then the column on the right where we list the number of times that each score occurs. That's what we call the frequency. So the score 70 occurred once, its frequency is 1. The score 71 occurred 5 times, its frequency is 5, and so on. This is probably easier to read than simply having the list of numbers in order. Easier to see what the data looks like. A third possibility would be a histogram or a bar chart. This is really just a picture of the frequency table. So the way this works is the possible values, in our case the test scores, are listed horizontally, and then the frequency of each value is the height of a bar above the value that's listed. So here's what the bar chart would look like for our data. The test scores are listed along the bottom of this chart. And then above each score is a bar. The height of the bar is the frequency of the score. So for example, the height of the bar above 71 is 5 because the score 71 occurred 5 times in the data. This is a nice visual way of looking at the data. But rather than organizing data like this, we're going to be interested in summarizing the data. And we'll be interested in two kinds of summaries. We'll be interested in a number that gives us the center of the data. And then secondly, we will be looking at numbers that describe the spread or the dispersion of the data, how spread out the data is. So let's look at the measures of the center of the data. These are called measures of central tendency. And the first one we're going to look at is the mean. The mean of a collection of numbers is what is sometimes called the average of the numbers. So if you look at the 6 numbers, 3, 5, 3, 8, minus 4, 7, the mean of those numbers would be the average. You add the numbers, and then you divide that sum by the number of numbers you added. So to calculate the mean of these 6 numbers, I would add the 6 numbers and then divide the result by 6. So that's what I've done here. The numbers are added in the numerator. I'm dividing by 6 in the denominator, and that'll be 22 over 6, 3.667, which I have rounded off to 3.7. Usually you round off the mean to one more accuracy place than the data. A couple of things to note here. The outer parentheses, this one and this one, may be necessary on some devices. For example, a graphing calculator, those outer parentheses will probably be necessary. Second thing to note here is that we usually round the mean to one more decimal place than the original data, as I've done when I rounded to 3.7 here. And finally, we usually think of the mean as being the center of the data, the center of the numbers that comprise the data set. So this is just one way of describing the center. Here's the official definition of the mean. I'm not sure this is necessary, but here's what it is in precise detail. Suppose we've taken a sample of size capital N from a large population and obtained a number for each member of the sample. Could be age, could be test scores. So if the numbers are x1, x2, and so on through x sub capital N, then the mean of the numbers is obtained by adding the numbers and dividing by n. So here's a more theoretical description of what we looked at in the example. Note that the usual symbol for the mean is x bar. Now we're looking at a second measure of central tendency called the median. The median of a collection of numbers is the center of the numbers when they are put in order. To make that more understandable, let's try this set of numbers, 3, 2, 2, 5, 1, 8, and 6. So to find the median, we'll first put the numbers in order. That would be 1, 2, 2, 3, 5, 6, 8, and then we locate the central number. Which is 3. Have to ignore this little typo here. This is the median, the central number in the data list. For larger data sets, it's helpful to be able to find the position of the median. So if you had 500 numbers in your data set, it might not be as easy to scan through the 500 numbers in order and find the median. So in our example, the position of the median is position 4. Right, the median is the 4th number from the left end of the data when the data is put in order. And you get 4 by calculating 7 halves and rounding up. 7 is the number of data values. So 7 halves is 3.5. If you round up to the next whole number, you get 4, and that gives you the position of the median. And in general, the position of the median in a data set consisting of capital N numbers, in our example capital N was 7, you can find by dividing n by 2 and then rounding up to the next whole number. Let's try one more median example. If you have an even number of data values and you want to find the median, there won't be a center number. There will be two center numbers. So for example, if we take the six numbers 4, 2, 2, 5, 1, 8 and put them in order, 1, 2, 2, 4, 5, 8. There isn't a central number, but there are two center numbers, namely 2 and 4. The two middle numbers in the data are 2 and 4. And when you have an even number of data numbers like this, you take the average of the two middle numbers to get the data. So we're going to add the two middle numbers and divide by 2. Let me back up just a little bit. So the median of this set of data is 2 plus 4 divided by 2. That's 6 over 2, which is 3. So one thing to notice here is that the median will not always be a number in the data set. It usually won't be if you have an even number of data numbers. Okay, and here's the precise description of the median. The example might be more understandable. So to get the median of a collection of numbers, you arrange the numbers in order. We're using little n now for the number of data numbers you have. If the number of numbers is odd, then the median is the middle number. So as we saw when we had 7 data numbers, the median, there was a middle number, it was in position 4, and that middle number was the median. And you get the position of the middle number by rounding up n divided by 2. What do you do if the number of numbers is even, if the number little n is even? Well, then the median is the mean of the two middle numbers. You take the average of the two middle numbers. The positions of the two middle numbers will be n over 2 and n over 2 plus 1. So this would be a short way of finding the positions of the two middle numbers when you have an even number of numbers in the data set. So why don't we try finding the median of this list of numbers. So there are 15 numbers arranged in order. So it's not too hard to scan through the numbers and find the middle one, although it's a little harder than our example where there were 7 numbers. But since we know there are 15 numbers, we could find the position of the middle number by dividing 15 by 2 and getting 7.5, and then rounding up to the next whole number, 8. The median of this set of data is in position 8. So counting from the left, 1, 2, 3, 4, 5, 6, 7, 8. The median for this set of numbers is 9. Okay, why don't we try this example where we are going to calculate both the mean and the median. So we have a random sample of 8 people chosen from graduates of a speed reading course, and their reading speeds were measured in words per minute, and here are the results. 1,000, 1,000, 850, 800, 800, 1,000, 600, 1,100. And we want to find the mean and median of this set of numbers. So here's a list of the numbers again so we can refer to it. And we'll start with the mean. We know that the mean is what usually you call the average. You add the numbers and then divide by the number of numbers. There are 8 numbers, so we will add and divide by 8, which is what I have done here. If I were doing this on a calculator, I would probably need parentheses around the top of this fraction, around the numerator. Okay, and when I did the calculation, I got 893.75, and then we would ordinarily round to the nearest tenth. 893.8 if you round to the nearest tenth. Let's try calculating the median. Here we'll put the numbers in order. Here they are listed in order: 600, 800, 800, and so on. And now there are 8 numbers here, so we want the average of the two middle numbers. This is a fairly small data set, so it's pretty easy to scan through the 8 numbers and find the 2 middle numbers. But let's try using what we know about the positions of the 2 middle numbers. Right, the first of the 2 is at position 8 over 2. Right, 8 is the number of data numbers, which is 4. And the second middle number is at the position 8 over 2 plus 1, which is 5. So the 2 middle numbers are at positions 4 and 5. Here they are, 850 and 1000. So the median is the average of those two, 850 plus 1000 divided by 2. And here's another case where if I were doing this on a handheld calculator, parentheses around the numerator would probably be needed. 925 is the median. So both the mean and the median and all the other numbers we'll talk about in this video can be calculated on a graphing calculator or on Desmos. But probably the best method is to use the descriptive statistics calculator at the Calculator Soup website. We have used this calculator fairly recently to get random samples. Here's the URL. This URL is probably clickable from the slides, but I doubt if it's clickable on the video. Okay, if you are using a graphing calculator like a TI-84 to calculate these numbers, you need to use the calculator's lists features. This is probably the hardest option, so I'm not going to describe this any further. I recommend using either Desmos or the Calculator Soup calculator. So in Desmos, to get the mean of a bunch of numbers, you type in the word mean, followed by a list of numbers in parentheses and separated by commas. Or if you're calculating the median, you would type in the word median, followed by the same kind of list. So for example, if you typed mean left parenthesis 3749 separated by commas right parenthesis, this would calculate the mean of those 4 numbers. And similarly for the median. This is a pretty easy tool to use for calculating means and medians. On the Calculator Soup calculator, you would type in the numbers separated by commas in the box labeled Enter Data Set. And then you would click on Calculate, and the mean would appear below the Enter Data Set box. Might have to scroll down a little bit to see it. Okay, so now let's look at calculating the mean and median from a frequency table. And I'm going to do this calculation by hand. And I want to go back to our example where we had 25 students who took a test, and we had their scores given by this frequency table. Right, so the scores were 70 through 78, and 70 occurred with frequency 1, 71 with frequency 5, and so on. And now we want to look at calculating the mean and the median from the table. Okay, so to calculate the mean, we have to add all the data numbers. So we have to add 170. We have to add 5 to that. We have to add 5 71s because there were 5 71s in the data set. To that, we have to add 2 72s, 4 73s, and so on. And then divide by 25, because there were 25 numbers in the data set. So the easiest way to do this, if you're doing it by hand, is to use a little bit of multiplication. Right, 5 71s is 5 times 71, and 2 72s is 2 times 72. You don't actually have to add all 25 numbers. And when I do this calculation, I get 1,848 in the numerator. I'm dividing by 25. I have rounded off to the nearest tenth. 73.9 is the mean or average of the test scores. Now for the median, we did have an ordered list of the numbers at the beginning of the slide presentation, and we could use that ordered list. Here's another possibility. What I'm going to do is add a cumulative frequency row to the table. Here's what I mean. We have the usual, the same 2 rows we had before, the scores and their frequencies, and now I've added the cumulative frequency row. So there's a 1 here. There's a 6 here, meaning that the total of the 70s and 71s is 6. And the 8 here is the total of the 70s, the 71s, and the 72s. The 12 here is the total of the 70s, 71s, 72s, and 73s, 1 plus 5 plus 2 plus 4. So we're keeping a running total as we go from left to right in this table of the number of data points represented. And the final running total, the final cumulative frequency, is 25. Okay, and now we get the position of the median by taking the number of numbers, the number of data numbers, 25, dividing by 2, and rounding up to the next whole number. That would be 12.5, rounds up to 13. So the median is in position 13. And now looking at the cumulative frequency in the bottom row here, the 75s start at position 13 and end at position 19. So the number in position 13 is a 75. So that's the median. This would probably be the way to do the median calculation from a very large set of data where you had a frequency table. So we will be looking shortly at using software to calculate from a frequency table. But first, let's look at some measures of dispersion, measures of how spread out the data is. The first of these is a fairly simple one. It's the range. It's simply the distance on a number line from the smallest data value to the largest data value. So you put the numbers in order, not really necessary for small data sets. And then the range is the largest number minus the smallest number. This is how you get the distance on a number line from smallest to largest. Not much to this kind of calculation, really. So let's try the numbers 4, 26, 5, 5, 8, and 2. I didn't bother to put them in order. 26 is the largest of those 6 numbers. 2 is the smallest. The range is 26 minus 2, or 24. The second measure of dispersion is what's known as the standard deviation. So we're going to look at an example shortly. But here's how you calculate the standard deviation. First of all, it's like an average deviation from the mean. Okay, in detail, you first calculate the mean of the numbers in the data set. And then number 2, for each number in the data set, you subtract the mean from that number. This gives you, roughly speaking, this gives you the distance from the mean to the number. And then you square each of these differences. And then you add up the squares. And then if there were capital N numbers in the data set, you divide by capital N minus 1. And finally, after step 5 is done, you take the square root. So we will work out an example by hand shortly, but it's almost always better to calculate the standard deviation using software. Sorry about that little glitch. And as I said, we will do an example by hand shortly. On Desmos, to calculate the standard deviation of a set of numbers, I'm just taking these 5 numbers as an example, you enter STDEV, short for standard deviation, followed by the list of numbers in parentheses separated by commas. On the calculator soup descriptive statistics calculator, in the enter dataset box, you enter the numbers separated by commas. You make sure just below the enter dataset box that sample is selected rather than population. And then click calculate. And the standard deviation will appear below. You may have to scroll down, along with the mean, the median, and a lot of other numbers. So the calculator soup advantage is that all these numbers are calculated at the same time. And now let's look at calculating the mean and standard deviation from a frequency table or bar graph. So we looked at calculating the mean of data from a frequency table or a bar graph, And now we're going to add the standard deviation into the calculation. So we're going back to the example where we had 25 students and test scores, and here was the bar graph. Although it's not completely necessary for what I'm about to do, I recommend constructing the frequency table from the bar graph if you don't have the frequency table. It's easy to do, and here is the frequency table, which could be constructed from the bar graph. It's the frequency table we had before. And now there is a spreadsheet which I'm going to post on Canvas, in which you can enter the numbers in the frequency table, and the mean and standard deviation will be calculated automatically. We'll see how that works in just a second. So the scores can be entered and their frequencies, and once the last score and frequency has been entered, the mean and standard deviation are calculated. So here's a screenshot of the spreadsheet, and I have entered the frequency table numbers from our example. Right under data values are the scores 70 through 78, and then in the frequency column I have listed their frequencies 1, 5, 2, 4, and so on. And I just note here that unless some other number is entered, the frequency of 1 will be used. So if you do not enter frequencies in the frequency column, frequency of 1 will be used. And then below the word mean, the mean of the data is calculated, and below the word standard deviation, the standard deviation of the data is calculated. I also have a median calculation here, but this only works if all the frequencies are 1. I may get that fixed up so that it works for any frequencies, but at the moment it doesn't. You can enter up to 49 values in this spreadsheet along with their frequencies, and as I said, if no frequency is entered, then a frequency of 1 will be used. And now let's try a standard deviation calculation the hard way. In other words, by hand. And I'm going to take a fairly small set of numbers, 47374. Okay, so as you recall, you first need the mean of the numbers, the average. So x bar, in this case, I add the numbers and divide by 5. And I got 5. The mean of the numbers happens to be 5. And now here is an outline of the remaining steps. So for each number in the data set, so xi represents the number 4, 7, 3, 7, and 4. You remember you subtract the mean from that number. Then step 2, you square the number from step 1. You square this number obtained by subtracting the mean from the data set number. And then 3, you add the squares. 4, you divide by n minus 1. In our case, there are 5 data numbers, so capital N is 5. So n minus 1 would be 4. And then finally, you take the square root. So several steps involved in this process. And if you're doing it by hand like I am here, it's easiest to set things up in a table. So here's a good way to set up your table. I've put the mean here just because I'm going to use it in these calculations. And I have listed the numbers in the data set in the first column. So xj will represent each of these 5 numbers. Okay, now in the next column, I want to calculate the previous number minus the mean. So in this square, immediately to the right of the first 4, I would calculate 4 minus 5, minus 1, and it would go there. And then in the next square to the right, we square the entry in the second column. Minus 1 squared, minus 1 times minus 1 is plus 1. So one thing to keep in mind is that squaring will always give you a positive number, positive or 0. Okay, here we are doing 7 minus the mean. 7 minus 5 is 2. Squaring 2 gives you a 4. 3 minus the mean. 3 minus 5 is minus 2. Squaring minus 2 gives you 4. 7 minus the mean is 2. We've done this calculation before. 2 squared is 4. 4 minus the mean is 4 minus 5 is minus 1. Minus 1 squared is 1. So I have subtracted the mean from each number. I've squared the results. And now the next step is to add up the squares. The sum of the squares is 14. And now 2 more steps, which I've done all in one line here. You divide the sum of the squares by n minus 1, that's 4 in this case, and you take the square root. So 14 divided by 4 is 3.5, and the square root is 1.8703. This is the standard deviation done by hand in this fairly small example.